All right, our first example question here asks if the two rectangular prisms are similar, and then how do we know? Well, if they're similar shapes, then all of their sides are in the same proportion with each other. So if, for instance, the height of this smaller shape compared to the height of the larger shape is the same as the width of the smaller shape compared to the width of the larger shape, and the length of the smaller shape compared to the length of the larger shape, then the two shapes are similar and they're just different sizes. So what we need to do here is see if we can find the scale factor between the two of them and then see if it applies to each of the different lengths, right? So if we take our first shape here and our height is 4, and our second shape, the height is 6, that's a ratio of 4 to 6, which reduces to 2 over 3. Yeah? Well, then if we take our length, or our width, I guess, we get 3 compared to 4.5. So 3 over 4.5 would be the same as 6 over 9 to make them whole numbers, which then reduces again to 2 over 3. So those two are the same ratio. And then finally we have 5 to 7.5. So 5 over 7.5. If we double both of those, we'll get 10 over 15. Now we have whole numbers again, and that reduces by 5 to 2 over 3. So yeah, all three of these have a ratio of 2 over 3. So these two shapes are indeed similar, and we know because the ratio is the same for all three dimensions. Okay, example B. The two cylinders below are similar if the ratio of the areas is 16 to 25. What is the height of the taller cylinder? So the area ratio is 16 to 25. So that tells us that the surface area of this one here compared to this one here is this one, if this one is 16 units, this one is 25 units. But what we know about the area ratio to the scale factor ratio is that the area ratio is the square of the scale factor ratio. So if the scale factor is A over B, then the surface area would be A over B squared, right? Well, this is what we have here. We have the surface area scale factor, and what we want to know is the basic scale factor so we can figure out how big the height is. That means we need to take the square root of the surface area scale factor so that we can get the base scale factor. So we're going to take the square root of 16 over the square root of 25. So our scale factor then is 4 to 5. Square root of 16 over square root of 5. If the scale factor is 4 to 5, then we can figure out our comparison here because we know that 4 over 5 is going to be the same thing as 24 over h, right? Because the little one and the big one and the little one and the big one, right? So we're going to cross multiply 5 times 24 and 4 times h. So we get 4h equals 5 times 4 is 100, or 5 times 20 is 100, and 5 times 4 is 20, so we have 120. Divide both sides by 4, and we get 120 divided by 4 is 30, so h is 30. Yeah, so first thing we had to do was take our ratio that they gave us, which was for the area, take the square root of the top and bottom, so we could find our scale factor, and then compare our scale factor to the two sides that we had to find the missing value. Okay, example C. Two spheres have radii in a ratio of 3 to 4. What is the ratio of their volumes? Okay, so this one goes the other way. Remember that our scale factor, if it's A over B, then our volume scale factor would be A over B cubed. So all we need to do is say, okay, if the two spheres have a scale factor of 3 to 4 on a single dimension, then it's 3 over 4. And then we just need to cube that top and bottom to find our volume scale factor, right? Or our volume ratio. So we have 3 cubed. Well, that's 3 times 3 times 3. 3 times 3 is 9 times 3 is 27 over 4 cubed. So 4 times 4 times 4. 4 times 4 is 16 times 4 is 64. So if two spheres have radii that are a ratio of 3 to 4, then their volume compares as 27 to 64. That's all we have. All done.